In this video, we'll be doing question 5 of the March 2025 common paper for KZN Grade 12. So they say that if sine 5 theta is equal to this, and they say we should determine these. So the first thing you do is take what you're given and try to make it a simple ratio where you can identify the quadrant. So if we take this and we transpose 4 to the other side, we are going to have 5 sine beta is equal to 4, and then we divide by 5 both sides. Now we have sine beta is equal to 4 divided by 5. Okay, now if sine beta is equal to 4 divided by 5, that means that sine beta is positive. And since they said beta is between 90 and 270 degrees, that means it's between the second and third quadrant. Now between the second and third quadrant, where is sine positive? Sine is positive on the second quadrant. So you could say all students take coffee. Sine is positive here and here. But also we said it's from 90 up to 270, which means since it's between these two, it has to be here. Now when you draw your diagram, you draw it here, and your beta will be this angle. Your opposite side has to be 4, and your adjacent side, your hypotenuse side has to be 5. Now you use the Pythagorean Theorem to find the adjacent side, since you have the hypotenuse and the opposite side. So the Pythagorean Theorem, using it, you would find that x is equal to the square root of 5 squared minus 4 squared, and x is equal to, now 5 squared is 25, 4 squared is 16. 25 minus 16 is 9. And the square root of 9, the square root, okay, plus or minus there since it's a square root, the square root of 9 is 3. Now x is plus or minus 3, but we know that x is negative here because it's on the negative side of the x-axis, therefore it's negative 3. Okay, now let's come here. Cos beta, according to our diagram, since this is negative 3, cos is the adjacent, which is negative 3, divided by the hypotenuse, which is 5. Now we need cos 2 beta. Cos 2 beta can be changed to be 1 minus 2 sine squared beta, using the double angle identity for cos. The reason why we're using this is so that we can remove the 2 from the inside. Now we only have beta, so what we're going to do is we will substitute sine beta, because we know what sine beta is. It's 4 over 5. So we have 1 minus 2 into, when you substitute sine beta in the place of sine beta here, you have 4 over 5, but sine beta is squared, therefore you square that. Now you have 4 squared, you can put this in a calculator. This is 4 squared, which is 16. This is 25. That's 16 times 2, which is 32. And underneath we'd have 25, but now it's 25 times 1 is also 25. I have 25 there. You have 30 minus 20 is 1. You have this 10, and then you have 12 minus 5. So it's 10 minus 5, which is 5. Okay, so this all adds up to minus 7 divided by 25. Right, this is minus 7 over 25. Now let's come to this one. This one is going to take a bit longer. Let's get a paper. So it's sine 3 beta. Let's try to simplify this such that it doesn't have any multiple of an angle. So this is sine beta plus 2 beta, right? Now we apply the double angle for sine. We have sine beta cos 2 beta plus cos beta sine 2 beta. Now we apply the double angle for cos here and apply the double angle for sine here. So sine beta, this for the double, we will use the double angle for sine 1 minus 2 sine squared beta plus cos beta. Then here we have 2 sine beta cos beta because we use the double angle for sine, which is this. Now you multiply this out. You don't need to multiply it out. You can basically substitute sine theta here, sine theta here, cos theta there, in there. But I'm going to try to simplify it. So if you multiply this, you're going to have sine beta minus, here you're going to have 2 sine cubed beta plus here you have cos squared beta times 2 sine beta. Right, now you can substitute, or if you think there's any other way to simplify, which there is, you can do that. I want to substitute sine once. See, we have a sine here, we have a sine there, we have a sine there. I want to substitute sine twice only, so I'll take it out as a common factor. Sine beta into 1 minus 2 sine squared beta plus cos squared beta times 2. Now let's substitute. Sine beta is 4 divided by 5. 1 minus 2. Sine beta is 4 divided by 5 squared plus cos beta. Cos beta is minus 3 divided by 5, but it's squared and it's multiplied by 2. Let me get out my calculator for that, to try and avoid wasting time. We have 4 over 5, have 1 minus 2 into 4 over 5 all squared plus minus 3 divided by 5 squared times 2. That's 44 divided by 125. Okay, now I want to show you guys a way to check if your answers are correct for such questions. I'm going to show you a way real quick. So how you check if your answers are correct for questions like this is, you see here, you had sine beta is equal to 4 over 5, had sine beta is equal to 4 divided by 5. You just say beta is equal to arcsine of 4 divided by 5, or I think you guys are used to using -1 here. It's the same if you say arcsine or say sine to the -1 and open a bracket and put in the ratio. And then you find the angle, you find the actual angle. So your beta is arcsine of 4 divided by 5, and your angle is 53,13010 ... So you know that it's in the second quadrant, and therefore it should be that beta specifically is 180 minus this angle, which is 53,130,100, whatever. So I'm gonna write now on my calculator 180 minus that, because that's where we decided sine is. No? I'm doing it on the side. That's 126,8698. Try to keep the commas. And not move them. So your beta is equal to 126,869,8976. Right. So how you check your answers once you have the angle? What you do is you just say cos. Okay, sorry. For this one, for the first one, which is cos beta, we're just gonna say cos of the angle we just found. You know the angle now. It should give us something. See, it's negative 3/5. There's negative 3/5. Right. And if you do this for all the other ones, so the second one was cos 2 times beta, and beta is 126,869,8976. So you're getting something with commas now. I'm getting negative 0,28. Negative 0,28. What you do if you get something like that, you just take this, you take what you got there, and see if you change it by S implies D, it gives you 0,28. I'm just going to check this one. I'm not going to check the last one for time's sake. So that was negative 0,28. It's 7/25. Negative 7,25. That's 0,28. That means our answer is correct. Let's move on to the next question. The next question says simplify, and they gave you this. So to simplify, the first thing you do is you can add 360 here. Add 360 here. So you have sine into negative 180 minus theta plus 360 degrees tan 180 degrees minus theta. We're still going to simplify. We just want to add 360. You see here there's nothing. So if you want, you can add 360, but you should know by head that cos of negative theta is the same as cos theta. But we haven't started simplifying yet. We're just adding 360 where it's necessary. I have cos squared 90 plus theta plus 3 sine squared theta. Okay, so now you say if you're adding 360 here, go to your calculator if you want. Say negative 180, which is this one, plus 360, and ignore the theta, the minus theta, because you're gonna bring it back. Your answer is 180. So you have sine, this gives us 180 degrees minus theta tan 180 degrees minus theta cos okay. So now we are simplifying. You can draw the cast diagram if you want to make things easier for yourself. Here you have theta. Here you have theta minus, you have 180 minus theta, 180 plus theta, and so on. So this is 180 minus theta. 180 is like this, minus theta brings us to this quadrant. Is sine positive or negative here? Sine is positive here because you have all students take coffee, or cast, C-A-S-T. cast diagram. Or hell, another period of maths. I think there was of algebra. I think there was something like that too for memorizing it. Sign this gives us that, so it's positive sign. We don't change this the ratio because it's 180, and for 180 you don't change the ratio. For 180 and 360 you don't change the ratio, so it's still going to be sine. It's going to be positive, so it's just going to be sine theta. For tan theta, it's 180 minus 2, which means it's in the same quadrant. Sine is positive here, but tan is negative, and therefore this is going to change to negative tan theta. I like to put brackets. It's going to keep you safer. You have cos negative theta. I said cos negative theta is the same as cos theta. Cos negative theta is the same as cos theta. Because cos here, you're saying negative theta, which means you're going in the opposite direction. You get to the fourth quadrant, cos is positive there. So it's the same as cos theta. Or just know that cos of negative theta is the same as cos theta. Now let's get to this one. We have cos squared 90 plus theta. So what I'm going to do is I'm going to take out the squared. I'm going to put it there. The squared. And let's deal with the inside. The inside says cos of 90 plus theta. 90, for 90 we know the sign is going to change. The ratio is going to change to sine. Right? Sine. And we are going to have theta inside. Now it's 90 plus. It's 90 plus, which means you are in this quadrant. But you don't ask what sign is in this quadrant. You ask the original ratio, which is cos. You say, is cos positive or negative here? Because it was cos originally. Cos is negative here, which means you have to put the sign as negative. But then it's squared, so it's still going to give you sine squared theta. Let's go to this one. We have plus 3. There's no way to simplify this, so we still keep it as sine squared theta. Okay, so now let us try to simplify the top. Let's change the tan into sine divided by cos. So you have sine theta, and you have negative. This tan, let's change it to sine theta divided by cos theta. Then you have cos theta there. And then at the bottom you have this is squared. Therefore, if anything is squared, it's the same whether it's positive or negative, right? So 2 squared is the same as negative 2 squared. So this is the sine squared theta plus 3 sine squared theta. Now this cos is going to cancel out with that cos, because this one is at the top. It's with the top ones. It's cos over 1. So if you multiply the numerators and multiply the denominators, the cos's will cancel because one is in the top and one is at the bottom. Now these signs though, they are both at the top, so they won't cancel, but they will multiply to be sine squared. But don't forget this negative sign. So you have negative sine squared theta at the top, and then at the bottom you have sine squared theta plus 3 sine squared theta, a single sine squared theta, and to that you are adding 3 sine squared thetas, which means you are going to have 4. Ne? You had 1 sine squared theta, now you're adding 3 of them, so you're going to have 4 sine squared theta. People like to say you take out the common factor and then they take out the common factor, which is sine squared, and then in the brackets you would have had 1 plus 3, which would have given you 4. But I like to just keep it straightforward. This is a single sine squared theta. These are 3 sine squared thetas. If you add these, you're going to get 4 sine squared thetas. So this is 4 sine squared thetas. Now this is going to cancel this, because they're the same. It's going to be equal to 1. These are going to be equal to 1. At the top, you're going to be left with 1, but it's negative. And at the bottom, you're going to be left with 4. Right. That's your answer. Negative 1 over 4. how you check this one is you go to the original equation or original expression. You write out the original expression, but in the place of theta, substitute any angle you like. So we have sine of negative 180. Let's say our angle is 30, so we say minus 30 degrees. Tan of 180 minus 30 degrees. And then you say cos of negative 30 degrees. Make sure you substitute the same angle for all of them. So you have cos 90 plus 30 degrees squared plus 3 sine 30 degrees squared. And your answer is negative 1 over 4. That is your answer. That means that you got the correct answer. That's how you check that one. Let's go on to the next one. The next one is a proof. We're getting a piece of paper. For the proof, my high school teacher always told me not to write this on my question paper, because if I write this on my question paper, then I'm stating it. So I shouldn't write this on my question paper. I should only write left hand side is equal to 1 over 8 into 1 minus cos 4x. Right, you might be asking, why are we starting with this side? Well, this side is way simpler than this side, because if you have like a 4 here, you have a lot of potential to simplify because you have a multiple. If you have a 2 here, you have a 4, you have anything else other than nothing, that means you can simplify that. But this is in the simplest form. So let's try to simplify this. When you try to simplify this, we're going to say 1 over 8 into 1 minus cos. Say, what I'm going to do here is I'm going to say 2 times 2x. Right, 2 times 2 still gives us 4, right? 2 times 2 still gives us 4. Now, to make things easier for you guys, what I'm going to do is I'm going to say let k be equal to 2x, or let 2x be equal to k. Okay? Or let's say theta, because you're used to theta. Let theta be equal to 2x. Theta is equal to 2x. Now, that means that your left hand side is equal to 1 over 8 into 1 minus cos 2 theta. You understand? The left hand side is equal to this because you substituted theta in the place of 2x. Now I have 1 over 8 into 1 minus cos 2 theta. There's a way that we can write cos 2 theta and we can simplify it. And that way, I think there are actually 3 ways we can write cos 2 theta, but I want a way that will cancel this 1 right here. I want to get rid of this 1. So if I want to get rid of this 1, and I know I'm going to have brackets for whatever identity I'm going to have, I would pick the identity that has 1 at the front, because the 1 is going to cancel this, and then they're going to cancel like that. The identity that has 1 at the front is the one that has 1 minus sine 2 sine squared theta. Okay, right, I hope you understand. I just substituted this in the place of cos 2 theta. I substituted 1 minus sine squared theta. That's a double angle for cos. It's an identity. Now let's distribute the negative sign here. We have 1 minus 1. Multiply that, we have plus 2 sine squared theta. Sorry, this is 8. Now the 1 and the 1 will cancel, and we'll just have 2 sine squared theta inside the bracket. And the 2, you can write 1 over 8 multiplied by 2 on a calculator, or you can say 8 has 4 times 2, so we cancel the 2's, you have 1 over 4 sine squared theta. Okay, now what you're going to do is you're going to substitute back the 2x, this 2x in the place of theta, because you can't simplify this any further. You can say substitute back theta is equal to 2x. Therefore, your left hand side is now equal to 1 over 4 sine squared 2x. Okay. Now, what we will do is we will use the double angle for sine, but let us put the squared outside first so it looks simpler, so that you don't have any problems. You have squared outside because the squared here means that you're squaring the whole thing. What we will do is we use the double angle for sine, have 1 over 4 into, if you use the double angle for sine, you have 2 sine theta, sine x cos x, cos x all squared. Now you have 1 over 4 into, you distribute the square inside the bracket. So if you have squared like this, remember there's something that says there's an exponential law that says ab squared is equal to a squared b squared, because you take the squared there, you take the squared here. Same thing you do here. You say 2, you take the square to the 2, you have 4, because 2 squared is 4. You take the square to the sine, you have sine squared x. You take the square to the cos, you have cos squared x. Now since you've distributed the square, you can multiply with the 1 over 4. If you multiply, this is just going to cancel, and since it's one term, you don't do the multiplying other things because this is all already multiplied together. And now your answer is sine squared x cos squared x, which is equal to your right hand side.